This is IBM Museum, and this video is about a little bit more testing of the IBM PS2 65SX, the planers I have. I've got 3 different planers and had one previously complete system that I had changed the planer on, so that was the 2 planers. And then I got another 65SX from Edgar Digital. I've had a very long live stream session, actually 2 of them this weekend, and going through to just trying to diagnose a little bit further. And I'm doing this video a little bit in inverse order because this is where I ended up, but I'll explain the steps that I went through a little bit earlier and provide that teaching moment where I can demonstrate of what I ran up against today. So let me get off the internal webcam. I'll get turned around, and I do have the camera most appropriately on this case. And this is my complete Model 65SX. And I've got the hard drive that actually came from the system from Edgar Digital in there, because that has that PC-DOS 6.1 that I put on that drive. Finally got it booting, and that was a lot of the live stream. Almost 8 hours of the live stream, 2 hours in one session, and then I continued through and almost went up to 6 hours in the second session. I did at the end actually fall back on, as a technician does, if you have replacement parts and can swap and known good parts, testing in a system to go a little bit further, and ruling out what the bad pieces are. Now, I had a thought earlier today that I've got these so-called clip over, and I'll demonstrate how they exactly clip over the CPU. But that is in the case of a 386SX CPU, and of course those are soldered on the planer. I've only seen one system way back decades ago that went through and had kind of a holder, because these are normally called the plastic quad flat pack for how they're soldered on a board. And I mean, it's viewed as a budget CPU. The 386SX, of course, has different markings on it than this, with the same package style exactly, as these things go through and they clip over the top of that CPU. And there's one particular strong issue with that, and that's what I ran up against. Now, the last time that these were visible on the channel, I got a few of them, and I went through and actually tried to stack CPUs, and I had a PS2 Model 50Z, which is normally a 286 CPU, and I had the Kingston module on it, actually a real nice 386SX, 33 megahertz, and that's got cache and everything else. And even though that enhances things, I got crazy, and I thought, what if I go through and clip on one of these? Now, the AMD is apparently just a slightly bigger package, and I had problems. It went through and it messed up some of the pins with a few of the modules that I tried, and it went through and ultimately it killed that Kingston 386 Now module. The system thankfully lives. It's with another CPU in there. It's fine. Well, no, that was not a 50Z. It was a PS2 model 3286. Get my stories right here. And the system's fine. In fact, you've seen that rather recently. I went through and did the postcode reader on that same machine. So an Intel, and I had the Kingston module set aside, and it's dead. I don't know if it's the CPU on that one, and I may have to go through it and replace some CPUs, and that's going to be disheartening. Or go through and actually get somebody to do it is a more likely scenario. But I had the thought, well, maybe I could try these again, and I wanted to see how easy it would go on the. Uh, Here is the board that was in the Edgar Digital system. And I've got one of the CPUs actually on there, one of the clip over CPUs. And the SIM socket retainers are good. This is the planar that I'm just not seeing anything. And my reasoning was that I think it's the CPU. And I was thinking that if it goes through and clips over, this is virtually a one-to-one connection, and it goes through and disables the CPU on the planar, and so it takes over. So if it was the thought is if it was a bad CPU, or most instances of a bad CPU, it would go through and it would do something. And of course, I want to go through and I wanted to test that first. I wanted to make sure that I could get a module on there like that, and so that would go through and work. I wanted to see this thing, a planar, turn over some postcodes. I knew it wasn't this particular planar. And so I have the planar that I struggled with a little bit on Saturday for my live stream, and where I was able to get it working. I have all the adapters and everything else clustered in here. But, even the postcode reader, all sorts of stuff. This is the original planar of this complete system. And I'd gone through, I was even holding down the SIMs because the retaining clips are busted on these. I've got masking tape in there now. But I had just a regular diskette holding down underneath the drive cage, holding down the SIMs in place as a way to have them contact. I've got to get a way that looks better. And so I swapped out the planars and had no issue with that, with putting the planar in to this system. Now, this system goes through and it functions perfectly good. I mean, sometimes I have to make sure that the SIMs are seated and things like that. But I'm not getting it to boot from a hard drive. And that was most of the hours worth of the Saturday live stream. I went through and I swapped everything. As you can see, I've marked the tribbles with the SCSI microcode. I tried different tribbles. I tried all sorts of different things, different hard drives, different cabling, and even as a last step, brought in my complete system that boots the hard drive fine. Boots with the components that I would go through and swap in that I was trying to test, and everything worked out good. Now the adapters here, and that'll play a part in this as well. I mean, we do have the postcode reader in the socket here. We'll end up placing that back in at some point. I do have the other postcode reader in a slot here, and then I even have an unboxing I need to do on another microchannel postcode reader, and I think people will really enjoy seeing that, and we'll see what steps it maybe can do for us in this case, because the 65SX goes through and it uses an alternate additional postcode port. Normally it uses the 680 for the microchannel, 680 hex for microchannel, and then it also has 681 as an auxiliary port that it goes through, and it kind of a subroutine or subcheck within that, within the postcode routine for the primary, it goes through and tests out the minor components of that subsystem. And so with this planar working, I went through And as I say, I'll demonstrate. And of course, you can see that I'll show the CPU here in a moment. That's a fundamental thing. I have some pictures too. I can probably demonstrate well enough from the camcorder, but I have to get the lighting just exactly right so that lettering will show up. Okay. And we see that it's marked in 80386 SX, 60 megahertz. And below that, we see that C step. And then it's got copyright date of 1985 and 1987. And that's kind of a critical thing to have that C step. And these are actually, Intel went through and licensed the code of the 386SX to IBM. And IBM went through and derived some CPUs from that. And I think one of the license agreements between the two was that it had to come in on an IBM system. It could not be separate. But that's where the 386 SLC, the 486 SLC2, and 486 SLC3 CPUs from IBM came from, derived from the Intel 386SX. Now, we go through and we want to match pin 1 to 1. There's actually a star silk screen on, or a little asterisk silk screen on the planar in that corner where, that upper corner where the I for Intel is. And we have the pin 1 marked on this, our little clip over as well. And thankfully the Intel, that's more the package that these are designed for, because it goes on easy compared to the AMD. And with just that single click, we are seated. And we'll go through and we'll test this out a little bit as it is. I want to go through and show what we have for that. And the postcode reader in there showed that it's operational. I didn't have to even go through to booting a hard drive or anything like that, but we will in this instance as a follow-up. But just seeing it go through and react and work this way, easily this way, I knew. Now, you'll notice that that's beneath, it's in the front of, and for the system from Edgar Digital, it actually had this particular adapter in slot 3. And of course, you could move it around. You'd have to go through the configuration again. But if you have an adapter in there, normally it's going to go through, and there's just going to be that little hairline of space above it. I mean, it does a normal adapter dimensions for 16-bit microchannel bus is going to work with that. And I just see if you had a 32-bit adapter, like the Tribble, that still looks like it would clear, because it even would clear between the crystal oscillators and things like that for the bus connection, just because it's right. I don't know if that was by design. Those crystal oscillators are split. And one of those is for the CPU. And that's going to come in, probably going to come in place as well. But we'll set this aside because, and kind of go back to, like I say, I do have, got to come up with some space to kind of scoot things around. Because I went through and I clipped on one of them and plugged in the postcode reader, ran the power supply. And we'll do that here in a moment with the other planar that worked. And again, nothing. And I knew that the CPU had worked. I went through the step. You want to go through and you want to test the component, make sure it functions in a good system, and then test it in your bad system. And as the one-for-one connection that it has with the 386SX, normally it goes through and deactivates that 386SX on the planer. And in this case, the CPU, I looked it over once, I didn't see any reaction. And I was so strongly suspecting that the CPU is not working. And again, I've got to get the right lighting. I tried to hold right side up for the lettering. Okay. Now you can see there that 80386SX. Gosh, get a better. I even have my ring light on. Okay, here's better. Okay. So it's the same CPU marking speed. We don't see that C step. We see the same copyright dates from 1985 and 1987, but not seeing that C step. And the marking of that C step was a relatively critical thing. It was done for a reason, that so people would know, looking and seeing C step, that they would know a clip over upgrade like this would work. And it was because on the initial 386SX, and it was only the 16 megahertz. I think by the time they got to the 20 megahertz and 25 megahertz at Intel, they'd already corrected the issue. But there's a pin on here called the float pin, and that has a negative mark in front of it. It's a negative signal when it's active. And it goes through, and it's provided by the upgrade CPU clipping over the top, that it causes the 386SX below, nestled in below, to float the pins of its connection. It takes them off all the address bus, the data bus. It just basically puts the CPU in an inactive state, so that the primary, the CPU that you're using over the top as the upgrade takes over the processing. You need that initial 386SX on the planer to go inactive. And it just clips over there one for one. Now, as I say, initially the 386SX had a non-functional float pin. And I'd always heard it was the A step of the 386SX. There's a B step, and then there's a C step. And I'll get through and I'll show the page here in a moment as well. But even when I went through that and encountered to where I couldn't get this planer to run, I thought, wouldn't it be great? I've got more of these. Let's try it on the complete 386SX I have here. I went through, plugged in this. This is easy here. I mean, it's got space around that CPU for me to go through and put in that. And I don't have one clipped in there right now. I've got this connected. We'll look at it in a moment. Because it didn't work. So I pulled it out. And I thought, let's investigate why this didn't work on here. Maybe that gives a little bit of clue of why going through and supplementing, bypassing the planar CPU functions with this also didn't work. And I'm really suspecting the crystal oscillator for the CPU now. If this is not working correctly, not getting a clock to, and it's actually the upper one there, that 32 megahertz, because it's divided in half for the frequency that the CPU operates at, even though it's 32 megahertz that goes into the CPU. There's just the divider in there that goes through and works with that as a clock signal. And it'll be real easy to go through and replace a 4-pin oscillator can. In fact, I'll put a socket on here, and that way I can go through and put, a 32 megahertz crystal to test. And I can also look at seeing what a slightly faster crystal, upgrading the system a little bit more, will go through and do. I don't want to get really crazy, but I'd just like to see if going through and providing a little bit higher clock will work without disrupting any of the other board functions. So part of my investigation as I went through, of course, I went through and looked at the CPU on the complete system here. And it looks like just like this one. It does not have a marking for the C step, but I was still not worried because I had thought impressions were that there was that B step as well. And even for the C step, and there were even later steppings, Intel didn't always necessarily mark that stepping on the chip itself. They did that as a convenience to being able to look at it. And there were even software programs that you could run on your 386SX to see if it was upgradable, to see what stepping it was. And we'll look at that. I thought maybe that's, something else that certainly that can't be an A step in there is what I thought. And I thought for the point that the 65SX had been released, that they'd gone through. I knew it was an issue with the 55SX, the desktop version of this, that you had to be careful on if you could go through and put a clip over upgrade, CPU upgrade in there. But I thought that it resolved all that with the 65SX. Even the later 55SXs, I thought the later planar was a little bit more of a guarantee that you weren't getting the A stepping 386SX. So I just wanted to check it out. Now I'm going to go through. Let's probably get back over, and I'll get myself back on screen here. And I could have gone through and probably set this up beforehand, but I'll get the I'll go through and try and see. Okay, there's my browser capture. And I will plug in. I had the 65SX page from all the live stream this weekend. But here is a page, and this is actually in my website. So this is something I've written up. I went through and wrote up all the interrupt functions that were particular to the PS2s. And this is the interrupt 15 hex function C9 hex that is on the 386SX and above systems, PS2 systems, because Intel, with the release of the 386SX and 386DX CPUs, and the form factor that's the 386DX was actually just the original 386 CPU. The 386SX was later, just to make it a budget model that was a little bit more crippled in a lot of functions. But they gave a CPU reset signature to that when the CPU started up, that the system had a BIOS that was written for that. It could save away that value, and that CPU reset told what family model and stepping that the CPU was. Even typically submodels differentiating between certain types of that processor. For instance, the 46SX from a 46DX, from a 46DX2, etc. Now, later on, and this was done, supported on the Intel 386SX, the 386DX, and the early 46 models of CPU from Intel had also the CPU reset signature. At that point, Intel went through and turned that into the CPU ID, an on-the-fly instruction that the CPU would report basically the same value as the CPU reset signature. And with the 46 series, there's actually an instance where some of the cache modes are changed that are the cache that's on the chip, either right through or right back, and that CPU ID actually changes depending on what mode that the cache is in. So that CPU ID may not match the CPU reset in those instances, but everything else right on. And of course, on through Pentium and up above, that CPU ID, and that became an established mechanism out there in the industry. Also, Intel went through to do it to stamp that you could get the string of genuine Intel from that to know what vendor did that CPU. And that's, of course, not in the original CPU reset. It's just a value for the CPU family and a value for the stepping model number, just a basic decoding, as it were. Now, on this page, and I'll provide a link to this in the video description. I've gone over this page before. In particular, I need to scroll down because it's typically in numerical order. And I go through and have a lot of text there of what is going on exactly. So this interrupt 15 function C9 hex goes through and actually it doesn't query the CPU. It just retrieves the value from where it has been saved away on those particular BIOSes that support this. IBM BIOSes in the PS2 series. In particular, if you have a PS2 with a 386SX or above, and that only rolls out the low-end models, the 8086 based or the 286 based models that came out initially, don't support that, of course. But all the later systems with at least a 386SX CPU, 386DX, go through and they do support this function call, and it retrieves it. And at the bottom of the page, which I'll get to in a moment, I've gone through and listed where that value for whichever particular PS2 is saved away, because there's different, PS2s. And maybe it doesn't have extended CMOS in there. It's not a microchannel model, or it's a lower end microchannel model like the 55SX. It doesn't have extended CMOS. But it's just retrieving that from where the BIOS saved it up as the first thing that it did when the machine started up. And going through, we'll have to scroll down, and I'll put it right in the middle over on the left-hand side. We have that CH equals 23 hex is the 386SX class. Intel did the 386SX a little bit different. They did, as instead of 03, like they did for the 386DX family, they did it as the 23 is that the first two characters to that, the value that is ultimately in the CH register, and this is what's being returned. And we'll see where those values are in memory space or where the system has saved them away. And then below that, and I pondered even what was the selection of the 23 hex for, and kind of a step, is it signifying a 286 to a 386, or kind of somewhere in the middle of a 286 and 386, because the 386SX has the same number of address lines and data lines as a 286 CPU, although it's got the 386 functions within the CPU, the ability to do 386 instructions and features. But as far as the bus side, it's it's got the same address and data bus as what a 286 CPU would have. So just a little bit of pondering. Why did they pick a 2.3 in this case? But we see below that it has the CL, and that's the low order register. Together the CH and CL, that's high and low, and that's typically the count register for the C denotation of that, but not really in this case. But CX together is the entire the CH and CL registers put together to have the so in the CL portion of the register, that low order area, it has the stepping in this case. It's got 04 in there. If it's that critical A step or that A0 step, meaning the initial 386SX that was released. It's the A stepping. And I don't know why they went up to 04 in this case, what in this case signified before this of why the 00 and 01, 02, 03. And that may have been just compared to the 386DX as well. But 05 is the B step. And then that 08 is the C step and later steppings. And that's as high as they go, just those three different values of 4, 5, or 8. So I was interested in going through with an operational system. Let's verify, it's not marked as a C step. So let's go through and kind of check a little bit further. Now I do have some instructions down here, and this is pseudocode. It doesn't necessarily have all the timing delays and things like that, interrupt disabling that you want to do in regular working code. This is just pseudocode for what you can, it gives you the idea of what you can develop into working code. And I show the examples of if that value is saved in extended CMOS, if that is in actually what's called the extended BIOS data area, the EBDA, like for an ISA PS2. Doesn't have extended CMOS, so it's got to save that value somewhere else. You say, where is that value saved? Well, down below that, I go through the different models and where, in fact, they save the values. And normally, if the PS2 is microchannel and has the extended CMOS, it will go through and save that to extended CMOS in a particular location for the family, the CPU family data that I have there in that second column. I've got the model in the first column, and we see under the 65SX, it's kind of towards the, get it scrolled up towards the middle, extended CMOS 0190 hex for the family data, and for the CPU model stepping data, that's extended CMOS in the 0191 hex area of extended CMOS. And in particular, the ISA model, since it's any model below the number 50 with PS2s, that has where there's, I mark it as extended BIOS data area at a particular offset. And even that changes sometimes. And I've got to fill out some of these values. I don't have exactly the true value for the extended BIOS data area, which can go through and change. I've gone through and tested some models. I do have it in parentheses of where that location is. I've tested that to make sure that it actually saves those values in. But we're going to be going through and working with this extended CMOS code here, the pseudocode. And in this case, we're actually going to just use debug. the system goes through and boots to a hard drive with PC-DOS, I've got debug. So let's go through. I will get that off the screen. I'll get myself off the screen and get turned around. And we're going to get this powered up. I will go through. In fact, I shouldn't have really necessarily taken myself off the screen because I'm going to go over to the video capture side. And let me get myself back up on the screen here. And I'll get to my keyboard. Get it from out behind everything. Okay, rather slow count for the memory as it goes from 8 megabyte to 16 megabyte. I should have encountered for that, but we can go through. I'm just showing how the background to this works and going through wanting to check certain details when something doesn't work, of being focused on one particular area by what I know, what I remember to the situations of that 386SX that you had to verify. It was a later stepping. And again, I'm thinking that that was the A step of the 386SX. It was supposedly only the 16 megahertz models, which the PS2 65SX has in it. So 386SX 16. So I showed up on the camcorder. We're almost there. At a later point, when I shift things on the bench, I will pause the video. That's extraneous when I go through and talk about testing and getting all that set up. Okay, and we've hit it. And I heard the click as it goes through. It doesn't fire up the SCSI drive until the end of that. Okay. I don't know why I'm getting a configuration error, but we'll follow along with that. We'll give it the reference. I got the reference diskette there. We'll just make everything happy here. Okay. Pressing enter. Time and date not set. Well, I set the time and date earlier, but I didn't set it from within with the reference diskette. I thought it would take and make it so the system would not complain. Oh my goodness, it's getting late. I don't necessarily have to always key in the exact time that it is. Okay. And thankfully, on a warm start, well, I was going to say it wouldn't count the memory on a warm start, but it does after you've exited the reference diskette. Maybe I should have gone through and I should have paused, or I should have known that setting or it's a notation for me in the future. Going through, even though you have a working configuration that's set on the system, if you have not gone through and set the time and date, and you try and you set it through DOS, which I did in this case, that does not, it's not preserved on the system to the real-time clock. It will still apparently prompt you for the reference diskette when you go through and turn the system on again. That's fine. And if it were longer sessions, I'd go through and pause this. Well, if I were monetized, I would not object either, because this would be monetized time for the video. But I'm not monetized yet by YouTube in any appreciable level, at least. And we can change that. We can make my channel bigger. We can go through and get more subscribers, get more views to my videos. That would monetize me. That would make me happy. And honest, we're almost there again. I guess I could go through after the fact, edit or whatever, but if I had more production level quality. Okay, so starting PC-DOS, this is where we wanted to get to. And see, it's still I don't have an autodetect.bat, but we're going to go through and we're just going to start up debug. And I'm going to go through and do that pseudocode. So I do an out, which is just simply an O in debug. And remember, debug talks natively in hexadecimal. So we're outputting to IO port 74 the value of 90. We are outputting to the IO port of 75 hex the value of 01. And we are inputting, querying the value of what is on IO port 76. And that's the 23. That is the family ID here. That signifies that 386SX family ID of 23 hex in this case. Okay, so we're going to do another output to IO port 74 again, the value of 91 this time. Output to IO port 75, the value of 01. We have to go through that sequence again, the entire sequence. Now debug, and for the timing loops of true code, you have to put in there where you're not interrupted in certain processes. You're you're putting timing in there so that you're not reading IO ports back to back, because that can cause errors. But in the case of debug, we're going through and we're putting them in at human speed on the keyboard. And so input from IO port 76, and that shows 05. So it's 2305 is effectively the CPU reset signature of the system. And if we remember, and get my browser, and I have to scroll up on my browser capture as well, because that's the pseudocode that we just put in. Okay. So scrolling back up to that area that the 386SX class is, if it was 04, that would be the A step. 05 is the B step. 08 is the C, D, or stepping any above that. So this is a B step CPU, which I thought it would have an operational float pin, and it does not. So I learned something, even for the B step, and it's still the 16 megahertz mols, I think. I think because all the 20 megahertz 36SXs show up that they as a 2308, the C stepping. And a lot of cases there, I don't think the C step marking was predominant with the 20 megahertz and above 36SX, because Intel had gone beyond that point. There was known that if it was a 16 megahertz mol, that you needed to confirm and see that C step stamping on there. Otherwise, you'd have to run software to tell. And that eased your mind that the clip over update, the CPU upgrade, would go through and work. So we're going to go through, and of course I'll take away the browser capture and just queue for quitting debug. But I'm going to go through and pause at this point because I'm going to go through and set up the bench of the system for that, for the where the case of that clip over update worked. So I will be back in just, we'll resume the video when I've got the bench set up correctly. So I think I've got everything set up to my bench like I need. And I'm going through and I've got all the adapters in place that came on that Edgar Digital system. I've got the parallel port postcode reader because that's going to be the most visible indication. And all we need to do is to see that it's running. We know that a CPU is functioning in that regard. And of course, I have my Sims taped down. I got the reference diskette handy in case I need it. I also have to have a PC-DOS boot diskette going. Because remember, on this particular player, this particular setup, it does not want to boot from the hard drive. But you can boot from a diskette drive and then shift over to the hard drive. I could have also not even had a hard drive in this instance if I had a bootable diskette, pull the hard drive subsystem out of there, and boot from the diskette, have debug on there would be a way to do it. And of course, you did see me leave up the webcam, and that's for the case that I'm going to go through and shift. Once again, you see the postcode reader turning over there. And we'll shift over to the VGA capture. And yeah, the 201 and all that, I'm actually going to turn this off. We're going to go through and 201 is a memory error. I just want to make sure that it's reading these. Do I need something sitting on there, holding those things down? Because I want to make sure that I'm not having to go through a configuration setup just for the fact of the Sims. You know, the Sims being not reading the Sims. As far as I know, I've got a valid configuration on this. It's going through. It didn't complain at least about the Sims that time. But let's go through. Let's give it the reference diskette. Let's satisfy all the ills. 162, 163. And this has less memory, so it counts, quicker. This has the planar memory. Now, keep in mind, as of right now, I've got the upgrade CPU on this planar. And we know that, it's running the show. I mean, if the system is booting up, and that may be causing the configuration errors. We're going to do escape here. We're just going to let it go through and do the iMac configuration. I've got all the ADFs of these different adapters on this reference diskette now. So it shouldn't ask for extra files or anything else. It has all those adapter files. And this is what I'd ultimately like to see with that system, that 386SX system. I mean, of the 65SX model. I'd like to see where it's able to run the upgrade CPU and have all the adapters and everything else We found it in the live stream. It's got just PC-DOS 6.1 on the hard drive. And in fact, that hard drive is now basically set up the way that I have the system and was functional. Okay. So it's probably going to prompt us, I would think, it's going to prompt us for time and date, but let's go through and check. If it goes through and doesn't, it'll go through and try and boot from the hard drive. Okay, I didn't see it prompt us. Oh, okay. So that's a time and date. I'm knocking diskettes on the floor. But with that faster RAM count, once the system is configured, it goes through and it runs through that quicker. And again, it's getting late. Okay. And we could look at the configuration and things like that, but that's extraneous to this. I will go through and I will put the diskette that I can boot from, because it should go through. It's got everything satisfied to the configuration, date and time, all that. Okay, and if I did not have the boot diskette in there, it would try the hard drive and just throw us into ROM basic. But at least this way I'm able to get it to boot and I can switch over to the hard drive. Okay, and we're going to exit out of the setup. As soon as we can. A little patience. Okay, so F3 for exit, Y for yes. And we're going to shift over to the hard drive. We're going to get into running debug. Okay, so we don't have a path statement. So we need to shift over to the DOS directory. We boot off the diskette drive that doesn't have the path. It sets up the CDOS in the path. Debug is in the DOS directory. We'll go through, do the same thing, output to IO port 74, the value of 90, output port 75, the value of 01, input from IO port 76, 04, that's the family, CPU family. We'll go through output to IO port 74, the value of 91, output to IO port 75, the value of 01, input from IO port 76, 11. So as 0411, and that actually correlates to the CPU reset signature of this clip over CPU upgrade. It's a 46 family class. This is the Texas Instruments 46 SLC. That's a clip over upgrade. Doesn't have any math coprocessor. Still is a SLC CPU style, even though it's 46. So the address bus, data bus, is the same as the 386SX. and also the 286, but internally it is able to run 46 class instructions. So that's why it reports that particular 411. Q for quit. We're actually going to go through and we're going to power down the unit. I will quickly go through because I don't need to go through and pause. But I'm going to pull that clip over upgrade off and just pull straight up. You can feel it's a little warm. I mean, these don't have heat sinks or anything like that. But I went through with that, and we're going to put the adapter back in place. With that process, I was able to verify that my clip over CPU upgrades work. Okay. We haven't changed the configuration other than that. But we're going to see if it wants to run through the reference diskette, if it senses that change. And remember, it's writing that value to the extended CMOS of what it's finding for the reset signature. So the contents of extended CMOS should change, but it looks like it's fine. It still have the bootable diskette in the diskette drive. Okay, cool. It didn't want to go through config, even though we switched back to the original CPU. Okay. And we learn so we don't make the same mistake again. That when we exit the setup program, so F3 to exit, Y for yes. Okay, we shift over to the C drive. This time we go immediately to the DOS directory and start debug. We go through the same sequence again, output to IO port 74, the value of 90. Output to IO port 75, hex 01. Input from IO port 76, hex 23. That's back to the 386SX CPU that we'd expect. Output to IO port 74 hex, the value of 91. Hexadecimal, remember, that debug always works in a hexadecimal format. Input from IO port 76, 08. So we have a 2308, and that, remember from our page, conforms to meaning the C step, just as the CPU is marked on the planer. I go through, if everything was unplugged, I'd hold it up to the screen again. And so we've confirmed now, quit to exit out of debug, that the B step is also affected, does not have an effective float pin on that B stepping of the 386SX 16 megahertz. I may need to go through, maybe from perspective of like the 35SX or 40SX PS2, I can go through. Those are 20 megahertz, and those are much later models. I'm pretty sure that they have the later stepping there. As I say, I think all the 20 megahertz, I think, is the C stepping, or later in that case. And it's not that prolific mark. Whenever you see that mark on the 386SX C-step, it was Intel thinking ahead of that matter, saying, well, if they don't run the software utility, at least they can visually verify that this is a C-step CPU. And it's the only time that Intel really did that otherwise with CPUs. To note that internal stepping, that you could run a clip over upgrade, and the 386SX being different from every other CPU as well, that they had those clip over CPU upgrades, like I've showed with that Texas Instrument. Even with the plastic quad flat pack 46SX CPUs, the upgrade was a separate socket and a pin that disabled, extra pin on that other socket that went through and made the CPU that's soldered to the planar float the pins or disable itself, go into that inactive state so that the upgrade CPU could work. So I hope this has been informative. It was an informative day for me learning that B step thing, and kind of a little bit more better grasp of these upgrades. I would love to get this planar that's benched behind me into a complete system, go through. It's not easy to go, to upgrade the CPU on like my complete 65SX. I end up having to desolder the CPU so it can take a clip over upgrade. And that complete 65SX system does look like an early model because it's a brown PCB. The other two boards I have are green PCBs that typically, as I say, for the planars of PS2s, IBM, a lot of the time those initial planars for a particular model were brown, and then IBM shifted to a green PCB later on. Although one of the green PCBs I have, that's in that Edgar Digital 65SX that I got, and it's the CPU or something else is not working there. So I still get to troubleshoot that. But I'd like to troubleshoot this and get it booting from the hard drive and come up with some way to where those SIMs are fastened down. Of course, with it in the case and that hard drive cage over the top of it to hold things down, I could go back and put in the diskette again, and I could run this clip over CPU upgrade on that to have a MUL 65SX running, that 46 class CPU from it. Kind of cool in a way, I think. Or upgrading. I'm going to do mark this down for the playlist of the CPU FPU upgrades and that playlist among others. But that's all I have for now. If you have not subscribed to my channel, otherwise, please subscribe. Please recommend to your friends that might be interested in this content too. But that's all I have for now. This is IBM Museum. Thank you.